Welcome to our discussion on division of fractions. You can see once again, not a lot of objectives. All we're going to do is divide these things. And the great news is you already know how to do this, because if you know how to multiply fractions, you know how to divide fractions. Because literally all you have to do is flip one of them and do multiplication. It's that simple. Okay, some quick vocabulary. The commutative property means that we can do things in opposite order and it still remains the same. So 4 plus 5 is the same thing as 5 plus 4. 2 times 3 is the same thing as 3 times 2. That's the commutative property, and it really only works for addition and multiplication. Division does not work that way, right? 8 divided by 4, you can think of as 8/4, becomes 2. But 4 divided by 8 becomes 4/8, which is a half. So division, the direction in which you go, right? 8 divided by 4, the direction is very important, because then 4 divided by 8 going in the other direction gives you a completely different solution. And the reason why that's important is because when we're doing division by fractions, we know that we have to flip something and turn it into multiplication. But what do we flip? We flip the second thing. We flip what we're dividing by. So 5 divided by a half, we can flip that and it becomes 5 times 2. Now, if you want to see this visually, here's our 5 units. A half unit, obviously, is you cut it in half. So now all you got to do is take those 5 units and cut them all into halves, right? And if we're dividing by a half, we're just asking how many times can 1/2 go into 5. And we can see that there's 10 of those things, and we get an answer of 10. But like I said, the easy step for division by fractions is to flip the thing that you're dividing by, it's called the divisor, and then turn into multiplication. So it'd be 5 times 2 over 1, which is just 5 times 2, and that is 10. Now, when we flip something, it's called a reciprocal. Again, vocabulary, who cares? But in case you see that word, that's what it means. A reciprocal is just a flat fraction that's been flipped over, right? So these are all reciprocals. 5/6 to 6/5. 1/4 goes to 4 over 1, which of course becomes a whole number. Just like a whole number, 8, which is really 8 over 1, becomes 1 over 8. Now, just like before, we can't work with mixed numbers. We got to change them into improper fractions to do any of these kind of operations. So 5 times 2 is 10. 10 plus 3 is 13. We change this to 13/5, and then we flip it, and its reciprocal is 5/13. All right, so now on to the meat and potatoes, dividing fractions. Well, to divide a fraction, all we do is multiply by its reciprocal, i.e., take that second number, flip it over, and then multiply. 5 times 2 over 1 is 10 over 1, which is 10, right? Here's another example. We're dividing by 4/3, so that's the one that gets flipped, right? And 2/5 times 3/4 is just 2 times 3, which is 6, over 5 times 4, which is 20. 6/20 reduces to 3/10. Or you can divide as you go if you get better at this. Or again, use technology to do the reducing for you. In fact, a lot of technology will even do the division and multiplication of fractions for you, depending on how fancy it is. But mixed numbers, sometimes you can do it in technology. Oftentimes you can't. At the very least, you would need to take this 3/4 and convert it, right, into its improper fraction. So 4 times 3 is 12. 12 plus 3 is 15. Make it 15/4. Now you got 5/8 divided by 15/4. Slap that into your technology and get an answer. Or flip it and multiply and get an answer that way. Either way, it's fine, right? It's always going to work out the same. So, what's really happening here is we have to put every division problem into the form of just one thing divided by one thing. And that dividend and divisor both need to be fractions. They can't be mixed numbers. They could be whole numbers, but remember, a whole number is really a fraction in disguise. It's just something over 1. And then if you want to check your answer and make sure that you got it correct, whatever answer you get, multiply it by that divisor, that second fraction, the original one, not the flipped over reciprocal one. And your answer should be back to your original dividend, that original fraction on the left. So for instance, 8 divided by 4 we know is 2. 2 times 4 gets us back to 8. See, that's what we're talking about by how you can check your work. All right, some practical applications. An electrician has 5 spools, each containing 10 feet of wire. He needs to cut pieces of wire that are 18¼ inches each. He wants to know how many whole pieces of this length can he cut from the spool. Solve the problem as following. We basically need to put everything into the same unit of measure, so we can't do feet and inches. So we have to change 10 feet into inches, and we know there's 12 inches in a foot. So that 10-foot spool becomes 120 inches. That's the first thing. So now we're taking 120 inches and we're dividing it by 18¼ But again, we can't divide by these silly mixed numbers, so we have to convert that into an improper fraction. 4 times 18 is 72 plus 1 is 73. So now we're saying 120, remember, over 1 divided by 73 over 4 becomes 120 over 1 times 4 over 73. Straight across, 480 over 73. And then you'd have to do the long division or slap it into your technology to get it back into a mixed number. And you see that you get 6 and 42/73 pieces, right? Well, they don't want to know how many whole pieces, so that basically they can only get 6 of these things out of it, and then they're going to have some leftover, right? 42/73 of one of these pieces. So they're going to have roughly a half. They're going to have about 9 inches left over. All right, so that is basically all that matters. Is we know how many we can get, which is 6. And depending on how many they needed total, if they needed 30, then we know we need 5 spools, because you couldn't use, you couldn't like splice a bunch of those little pieces together. You're still going to need five spools. And that's all I got for you.